This question that we have a ice cube hanging in middle of oil and water with some mass submerged in water and the rest in oil. The specific gravity of ice and oil is given to be 0.9 and 0.8 respectively. We need to find out the ratio of volume of ice immersed in water to that in oil. So for finding out the ratio of volumes, let this height be h2 and this height be h1. The ratio of volumes will be equal to ratio of volume in water to that in oil will be equal to h2 by h1. That is h2 into area into h1 upon h1 into area. A cancels, therefore this is equal to h2 upon h1. So our aim now is to find out h2 upon h1, where h2 is the height submerged in water and h1 is the height in oil. So for finding out this, let us draw the force body diagram of the block of ice. This is oil, this is water. For this ice, this is h1, this height is h1, this height is h2. The forces acting on this are, instead of solving by buoyant force in this case, because there is no single liquid, we choose the method of pressures. If you solve the question by pressures, it is equivalent to using buoyant force. But since there are two different liquids, we choose the method of pressures. Let the pressure on top be P top. The pressure at bottom is equal to P bottom. And the other force acting on this is mg. So we can write Pb minus Pt into area is equal to mg. By Newton's law, applying Newton's law on this block of ice in the vertical direction, we get Pb minus Pt into A is equal to mg. So we just need to solve the values of Pb and Pt and put it here to get the final answer. Let us find out what Pt is. Let this height be x, that is the height of the top of the block from the surface be x. Now Pt is equal to P naught plus rho oil. P naught is the atmospheric pressure, rho oil into G into X. Pb, that is the pressure at the bottom, is equal to P naught plus rho oil into X plus H1. Now this is the pressure at the top of water. Now going a height h2 below water, this will add rho of water into G into h2. So this is the formula for the pressure at the bottom of the cube of ice. So this is rho of oil and this is rho of water, that is the density of water, into G into h2. When we subtract Pt from Pb, we get rho oil, this is rho oil, that is the density of oil, into, here it is also multiplied by G, into G into H1 plus density of water into G into H2. Now rho oil into G into H1 plus rho of water into G into H2 multiplied by the area of cross section of this block is equal to m into G. Now the mass of this block of ice, this is ice, is equal to density into volume, that is equal to A into H1 plus H2, this is the volume, multiplied by rho of ice into G. A gets cancelled, G gets cancelled also, so we get rho of oil into H1 plus rho of water into H2 is equal to H1 plus H2 into rho of ice. Now let us divide both the sides by rho of water. rho ice upon rho water is the specific gravity of ice, that is given to be 0.9. So we replace this by 0.9. Rho of oil upon rho of water is specific gravity of oil, that is given to be 0.8. So we write this as 0.8. This term is already 1. Rho water upon rho water, so we write this as 1. On solving this we get 0.1 H2 is equal to 0.1 H1. Therefore we get H2 is equal to H1, and the ratio H1 upon H2 is equal to 1:1. So our final answer for the ratio of volume of ice immersed in water to that in oil comes out to be 1:1. The important thing which you should have noticed in this question, or should have analyzed in this question, is that rather than solving by the formula of buoyant force, which we could not apply directly here, we choose the method of pressures to solve the question easily.